Alright boys, so I got a stack of bricks, 2 of them, 2x4 on top. Then I got some baseboards and some paper, a couple paint cans stacked as rolling wheels, and then I glued together 2 more baseboard pieces that are like this. And then I just rigged the drill on it. And I lined it up perfectly with my pilot hole. And if given enough time, my theory is that this will drill a perfect hole through the flange. So I don't have to keep breaking bolts. I got a pile of broken bolts all over. Or broken bits. And it's tough laying down here for hours and hours just holding onto a drill and not breaking these brittle little bits. So the diamond bit goes slower, but at a nice slow speed it will grind its way through gradually. I just use twist ties around this board, and I just strategically hot glued it in place. I can remove the hot glue with rubbing alcohol later. I just tacked it down in a couple key spots here and there, and then I twist tied off the trigger at the speed I wanted. I could go faster, but there's no rush. I'd rather slow and easy and more guaranteed, is my theory. And without me having to lay down here to watch it or to hold it, I'm not so worried about it being slower. I'd rather have it guaranteed so I don't have to mess with it anymore after I get it set up. The paper was key to really get the fine-tuned height to exactly what I wanted, down to the millimeter. So it's actually in my pilot hole right in the center of it. And also, since my driveway is pitched downhill, these naturally want to roll downhill. With this weight on top, it wants to glide right off these cans. So I don't even need a spring. Originally I thought I need a spring to be pulling it that way to create force, but the downhill slope naturally took care of that. So it's just perfect, really. So I think this will work out great. It's pretty cool, boys. I'll take it. Alright, I got the speed up a little bit more now. And I added a couple pipe wrenches leaning on the back just to add a little bit more pressure in that direction on the bit. So we'll see how fast it cuts. I don't know. I also sprayed it with water. ChatGPT said spray it with water every now and then, so I can just spray it with water, keep it cool. I don't know how much heat's going to generate though. It's probably got about 4 pounds of pressure from my estimation, and it looks like 7 revolutions per second. So I don't know how you'd calculate what it should. I don't know if you can calculate. There's probably too many variables, so I don't know how fast it'll go, but I feel like even a turtle pace is better than me sitting here doing it myself. As long as I can do other things, I guess. I'll just check on it now and then. I don't know. I'm watching it more at the start, but I might watch it less over time. Alright, I've been drilling with that setup for about 3 days now. And it's the same hole for 3 days. So needless to say, I've done like 7 bit changes, and each time I put a bit in, it makes some progress, but eventually jams up. Maybe after like 15 or 20 minutes, it eventually stops progressing. And I think a lot of that has to do with the metal that it's removing kind of getting jammed up or glazing the bit. And then the bit no longer
makes progress. Unless if you clear it out or resharpen it, depending on what kind of bit we're talking about. With the diamond bit, all the diamonds on the very front part of the bit were removed, and then no more diamonds were in contact. It was just metal on metal, smooth metal, and it no longer progressed. With the aluminum oxide grinding bits, they would get glazed, where the front became shiny and just covered in little metal specks that got really smooth and compressed and caked into place, creating a smooth surface on smooth surface, no longer removing material. With my carbide burr bits, they were getting dulled, which makes me think they were fake carbide. It wasn't really carbide. So maybe that would work if I had real carbide, but these were getting dulled pretty easily. Although they might have been real carbide because I broke a carbide 1/8 inch regular drill bit in the hole. Maybe they were still contacting that and that was dulling them. But I don't think that's the case because they were dulled all around the whole area they were touching any metal. So I don't think that was the case, but it's a slight possibility. So I wouldn't rule that out entirely. But ultimately, I found a YouTube video that said to use tile and glass bits, which have the it looks like a guitar pick on the top that's just seated into a drill. That worked great. That seems to be the best option. It's not even made for metal drilling, but it works amazing for metal drilling. I don't know why they don't advertise it as a metal drilling bit. You can buy something like this on Amazon. If you look up professional masonry drill bit set, 10 pieces for glass, brick, plastic, cement, wood, tile, etc. Industrial strength carbide drill bit tip, 1/8 inch to 1/2 inch, $6.98 for a 10-piece set. Can't beat that, and free shipping. That will work. So I'm seeing amazing results from this, and I think the big difference, number one, it's carbide and it's real carbide, so there's no false advertising issues. Carbide is the hardest of the hard things besides diamonds, but diamonds can come off or get clogged up. The reason this is superior even to diamonds, I believe, is it can't get clogged up because it's just got like the guitar pick on the top with large voids on either side of that guitar pick shape, and that allows, and then it has flutes, thick large flutes beneath that, unless if you get like the kind that doesn't have flutes, that's just straight shaft. I think that would be fine too though, because it would have a gap between it and the hole diameter, because the shaft, the smooth shaft, would be smaller than the diameter of the hole because the cutting head's larger. So needless to say, the powder is not getting jammed up in there. It's able to make its way out very easily, even with this horizontal cut. And the powder making its way out means no issues with that getting gummed up in there and stopping the cutting action. So it looks like this is going to be the ultimate bit for the job, especially if you're dealing with a broken tap or a broken extractor bit or a broken drill bit inside a bolt that's also hardened steel, and you're having to go through all of that. Then you need something that's bomb proof, and this really is bomb proof, and it's the ultimate, and it's cutting faster than any other thing I've tried, and I was just amazed. I could hardly take my eyes off it. So I have it set and it's drilling as we speak, and I can't wait to check on it in like a couple hours.